All right. So one last thing I want to show you guys is before we go and print all of our parts and start assembling this thing is a good rule of thumb is that like if you have a larger part and there's something that like you're trying to press fit in or like you're not sure of exactly how it's going to fit, a good rule of thumb is to print out if you could print out like a small scale version or like just the part that attaches that does the actual attaching so that it's like a quick print that is low on material and you can test to see if it works first before you print the whole thing. That might save you a ton of time because if you print the whole part and it doesn't work, well, what do you do now? You have to go back and make a change and then you still don't know if that works. So what if you have to print it again and then that may not work either? So it's good practice to print a small version, iterate. If that doesn't work, iterate until it does work, until you like how something fits. And then once you're good with those changes, then you go and print the larger version. Um, this will save you a ton of material and a ton of time, and it's something I do for all my projects. So there's a couple of areas that we need to make sure that work. If our make sure that our clearances and how much space we're allotting for everything work. Um, the first thing that we're going to go over is the jaw. So basically, the servo horn on the servo is going to slide into this little recess that we made, and you could use a little hot glue to secure it in place, but my goal is to make it tight enough that it's not going to move on its own and it'll just be like snug press fit in there. So let's go back to our jaw design. I'm just going to slide up our slider in the feature tree. And then we're going to go back to this boss extrude determines how much space is around the servo horn. So if we open up the sketch, we'll see that so this reference outline is the exact geometry from the GrabCAD model of the servo horn. And then we took that as reference and we made it construction geometry. And then we did an offset and gave 0.25 millimeters of clearance on all edges to give space for it to slide in nicely, right? Well, I did a bit of testing, and this is what we're going to do right now. And 0.25 was a little too much space for me for my liking. So what worked for me was half of this was 0.125. And once again, this is going to be something that we're going to have to experiment with. But I think this is a better starting point because I wanted it to be like really snug and really just fit on there. So we're going to go and close this. And then what we can do from here is what if we just printed just this arm piece, right? So I'm going to slide up to just like temporarily get rid of this fillet, right? And then if I go to direct editing, split, or you could search for the split feature using the search, and now we have to pick a trim surface. So if you use this plane, and then you pick this body, and you press cut bodies, you click those two, and then you press consume cut bodies, boom. Now we have a smaller scale version of what we're trying to print. This will take, a couple hours tops to print, less material, and we can confirm that that's the fit that we like before we move forward. So what I'm going to do here is I'm just going to, while it's in this state, do save as new, STL, and then maybe we make a new folder just for like test fits. And I'll name this servo jaw holder, whatever, or arm, something like that. So now we can test print that and then see how everything fits before we go and print the final parts. And then if it's too tight, then we just go back and change it or modify it, and we keep doing that until we like it, and then we print the final version. So I'm just going to get rid of this split and then go back down. And you could do this for any area that like you're unsure of like how something's going to fit. The only other spot that like I'm a little bit concerned about like how things will fit is where the stepper motor is going to fit. So like we gave Let's open this up. So I'm going to hide everything else except the body. And then what if we did another split? Basically, I'm trying to print a small version of like just this piece to see if it, here, let me explain. So there was this feature, right? And this inner line is like the exact geometry that we took from the GrabCAD part, and we did a 0.25 millimeter offset. We want to make sure that that's enough space to do a like tight fit for the stepper motor, so it's not wiggling around. So we're gonna do the same thing. I'm gonna use a split feature, and I think we have a plane that we built that feature on. Oh, maybe not. Okay, so what if I click this surface and this surface and this surface, and then I press cut body? Oh, okay, maybe a lot to select here. So I want to keep this. I want to get rid of oh, you can click it in 3D space too. That's cool. So I want to get rid of everything that's not this little piece. And then make sure consume cut body is checked and press OK. So now we have this portion that's just the part that we're trying to test. So I'm going to make a new sketch on the bottom here just to like close this off. So there's a little bit of a ground part to it. I'm going to just do convert entities on this face, extrude, just like something small, like 3 millimeters. And then we also don't need this extra piece to be this long. So yeah, you could do like whatever quick and dirty version works for you. And we're basically just trying to create a small scale, like easy to print version of this to quickly test if this will fit. So now there we go. With like a couple of features, we have a small scale version, and we're going to test to see if our stepper motor fits in here. Because if we didn't do this, like, look how big our part is. Like, imagine you print this whole thing and it doesn't fit. That would stink. So now we have a small scale version. I'll save this out. So save as new, STL. Go to the STL folder, test fits. Name this like stepper motor holder. All right, boom. Now we have a small scale version to test to make sure that it fits. I'm just going to delete these. So if it doesn't fit, then you go back to this sketch and you can make this larger or smaller based on how snug you want your design to be. All right, so the last thing I'm going to test fit before we move on and print out and make sure the fit is good is the stepper gear. So I'm going to show my stepper gear. And this boss, so that's just the gear teeth, and the cut was what we want to modify. So I know just based on trial and error that 0.25 worked really well for me. 0.25 is a good starting point if you want to print a tight press fit. We basically want to press fit onto the motor shaft of the stepper gear. And 0.25 worked for me, so we're going to print this out and test that. Okay, so I'll hide everything else. And then I'll just do save as new, STL, test fits, STL, stepper gear. Cool. So we'll print that out, make sure that that fit is good. If it's not, we'll go back to this cut extrude and either tighten it if it needs to be tighter or loosen it if it's too tight. All right, so for the tolerance on the jaw, let's see. the servo horn first at like an angle. Let's see if this fits. Okay, that's actually like a really nice press fit on there. So you see how that goes in, and it's pretty snug on there. Like this can rotate up and down. That's what you want. We also got to test our stepper motor gear. See how this fits? You want this to be pretty snug as well. Yeah, that's good. That's really good. So you're gonna have to play with these tolerances until you get how it should fit correctly. And then we got our ultrasonic sensor. That fits nice. It's okay if it's a little loose. We're gonna hot glue it into position. Oh, the last thing we want to test is how the stepper motor fits into this little well right here. And that's good. These my stepper motor is a little bent right here, but it fits well into these tabs, and then it catches into these corners here, so it can't rotate, and it's pretty snug in there. And then once we have the support plate here, it'll really hold it down into position and won't be able to move.